In this chapter, we are going to learn about integration. In the previous chapters, we have learned about differentiation. Integration is the antiderivative of differentiation. Once again, integration is the antiderivative of differentiation. A function have only one differential, but the same function have infinitely many antiderivatives or integrals. Let phi of x be an antiderivative of a function f of x. Then phi of x plus c is also antiderivative of the same function f of x, where c is a constant of integration. This constant of integration c changes. So we are saying that a function has infinitely many integrations. Here f of x is called integrand, and phi of x is called integral. The process of doing integrand to integral is called integrating. For doing problems of integration, first we have to learn some results of integration. For doing problem, some results of integration are 1. Integration of x raised to n dx is equal to x raised to n plus 1 divided by n plus 1. Second, integration of dx equal to x plus c, where c is the constant of integration. 3. Integration of sin x dx is equal to minus cos x plus c. For remembering, we know derivative or d by dx of cos x is equal to minus sin x. Removing d by dx from here, we will get cos x, and put an integration sign here, then integration of minus sin x implies that minus cos x is equal to integration of sin x. That implies that minus cos x plus c, we are adding a plus c here, which is getting integration of sin x dx. When we are removing c from here, we are putting dx here. Then the result will come integration of sin x dx is equal to minus cos x plus c. Fourth one, integration of cos x dx is equal to sin x plus c. For remembering, we know derivative of d by dx of sin x is equal to cos x implies that sin x is equal to integration of cos x. We are removing d by dx from here and putting integration sign here. Implies that sin x plus c is equal to integration of cos x dx. Here we are adding c left side and putting dx here. Then the result will come integration of cos x dx is equal to sin x plus c. Fifth one, integration of sec square x dx is equal to tan x plus c. For remembering, we know d by dx of tan x is equal to sec square x implies that tan x is equal to integration of sec square x implies that tan x plus c is equal to integration of sec square x dx. Sixth one, integration of secant x tan x is equal to secant x plus c. We know d by dx of secant x is equal to secant x tan x implies that secant x is equal to integration of secant x tan x implies that secant x plus c is equal to integration of secant x tan x plus c. Seventh one, integration of cosec x cot x dx is equal to minus cosec x plus c. We know d by dx of cosec x is equal to minus cosec x cot x implies that cosec x is equal to integration of minus cosec x cot x implies that minus cosec x is equal to cosec x cot x implies that minus cosec x plus c is equal to integration of cosec x cot x dx. Eighth one, integration of cosec square x dx is equal to minus cot x plus c. For remembering, we know d by dx of cot x is equal to minus cosec square x implies that cot x is equal to integration of minus cosec square x implies that minus cot x is equal to cosec square x implies that minus cot x plus c is equal to cosec square x dx. Ninth one, integration of 1 by x dx is equal to log x plus c. We know d by dx of log x is equal to 1 by x implies that log x is equal to integration of 1 by x implies that log x plus c is equal to integration of 1 by x dx. 10th one, integration of a raised to x dx is equal to a raised to x divided by log a plus c. For remembering, we know that d by dx of a raised to x is equal to log a into a raised to x implies that a raised to x is equal to integration of log a into a raised to x equal to log a into integration of a raised to x. Since log a is a constant, we can take out of integration. Implies that a raised to x divided by log a is equal to integration of a raised to x implies that a raised to x divided by log a plus c is equal to integration of a raised to x dx. 11th one, integration of 1 by x square dx is equal to minus 1 by x plus c. For remembering, we know that d by dx of 1 by x is equal to minus 1 by x square implies that 1 by x is equal to integration of minus 1 by x square implies that minus 1 by x is equal to integration of 1 by x square implies that minus 1 by x plus c is equal to integration of 1 by x square dx. 12th one, integration of e raised to x dx is equal to e raised to x plus c. 13th one, integration of root of 1 minus x square dx is equal to sin inverse x plus c or minus cos inverse x plus c. For remembering, we know that d by dx of sin inverse x equal to 1 by root of 1 minus x square implies that sin inverse x is equal to integration of 1 by root of 1 minus x square implies that sin inverse x plus c is equal to integration of root of 1 minus x square dx. 14th one, integration of 1 by x square dx is equal to integration of tan inverse x plus c or minus cot inverse x plus c. For remembering, we know that d by dx of tan inverse x is equal to 1 by 1 plus x square. Implies that tan inverse x equal to integration of 1 by 1 plus x square, implies that tan inverse x plus c is equal to 1 by integration of 1 by 1 plus x square dx. 15th one, integration of 1 by x into root of x square minus 1 dx is equal to sec inverse x plus c or minus cosec inverse x plus c. For remembering, we know that d by dx of sec inverse x is equal to 1 by root of x into root of x square minus 1, implies that sec inverse x is equal to integration of 1 by x into root of x square minus 1, implies that sec inverse x plus c is equal to integration of 1 by x into root of x square minus 1 dx. For doing problems, you want to learn some properties of integration. Some properties of integration. 1. Integration of f of x plus g of x plus f of x the whole into d of x is equal to integration of f of x dx plus integration of g of x dx plus integration of phi of x dx. Second one, integration of c into f of x dx is equal to c into integration of f of x dx, where c is a constant. C we can take outside of integration. So integration of c into f of x dx is equal to, we are taking c outside of integration, equal to c into integration of f of x dx. Then we are going to, before going to part 2, we do some basic problems based upon the given results and properties. First question is x raised to 10 dx. This we can compare with the result integration of x raised to n dx is equal to x raised to n plus 1 divided by n plus 1. Here n is equal to 10. Therefore, integration of x raised to 10 dx is equal to x raised to 10 plus 1 divided by 10 plus 1 is equal to x raised to 11 divided by 11 plus c, constant of integration. Second question is integration of x raised to 3 by 2 dx. This also we compare with the result integration of x raised to n dx is equal to x raised to n plus 1 divided by n plus 1. Here n is equal to 3 by 2. Therefore, integration of x raised to 3 by 2 dx is equal to x raised to 3 by 2 plus 1 divided by 3 by 2 plus 1. This is equal to x raised to 5 by 2 divided by 5 by 2 is equal to 2 by 5 into x raised to 5 by 2 plus c, which is constant of integration. Third question is integration of 1 by cube root of x dx. This we can also write as integration of 1 by x raised to 1 by 3 dx. This is equal to integration of x raised to minus 1 by 3 dx. This is equal to, this we can also compare with the result integration of x raised to n dx is equal to x raised to n plus 1 divided by n plus 1. Here n is equal to minus 1 by 3. Therefore, this is equal to x raised to minus 1 by 3 plus 1 divided by minus 1 by 3 plus 1. equal to x raised to 2 by 3 divided by 2 by 3, which is equal to 3 by 2 into x raised to 2 by 3 plus c. C is the constant of integration. Fourth question is integration of 3 raised to x into e raised to x dx. This also we can write as 3 into e raised to whole raised to x dx. This we can compare with integration of a raised to x dx is equal to a raised to x divided by log a. Here a is equal to 3. Therefore, integration of 3e the whole raised to x dx is equal to a raised to x. A is equal to 3e. 3e the whole raised to x divided by log a instead of a here 3e plus c, which is the constant of integration. Fifth question is integration of 1 by 2 root x dx. This we can also write as integration of 1 by 2 into 1 by x raised to 1 by 2 dx. This is equal to 1 by 2 into x raised to minus 1 by 2 dx. This is equal to 1 by 2 into x integration of x raised to minus 1 by 2 dx. Integration of c dx is equal to c into integration of dx. We can take c outside of the integration. This we compare with integration of x raised to n dx. Here n is equal to minus 1 by 2. Therefore, this is equal to 1 by 2 into x raised to minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1. This is equal to 1 by 2 into x raised to 1 by 2 divided by 1 by 2. This 1 by 2 should be cancelled. Therefore, this is equal to x raised to 1 by 2, which is equal to root x plus c, which is the constant of integration. Sixth question is integration of 1 divided by 1 minus cos square x dx. This is equal to integration of 1 divided by, we know that 1 minus cos square x is equal to sin square x dx. This is equal to integration of, we know that 1 by sin square x is equal to cosec square x dx. But we know that integration of cosec square x dx is equal to minus cot x. Therefore, this is equal to minus cot x plus c, where c is the constant of integration. Seventh question. Integration of sin x divided by 1 minus sin square x dx. This is equal to integration of sin x divided by 1 minus sin square x is equal to cos square x dx. Equal to integration of 1 by cos, we split into cos x and cos x into cos x. 1 by cos x into sin x by cos x dx equal to integration of, we know 1 by cos x is equal to sec x and sin x by cos x is equal to tan x dx. But we know that integration of sec x tan x is equal to sec x. This is equal to sec x plus c, where c is the constant of integration. Eighth question is integration of cos 2x divided by cos square x sin square x dx. This is equal to integration of, we know cos 2x is equal to cos squared x minus sin squared x divided by cos square x sin square x dx. This is equal to integration of cos square x divided by cos square x sin square x minus sin square x divided by cos square x sin square x the whole into dx. This we can cut cos square x, sin square x, sin square equal to 1 by sin square x minus 1 by cos square x into dx. This is equal to integration of, we know that 1 by sin square x is equal to cosec square x minus 1 by cos square x is equal to sec square x dx. This is equal to integration of cosec square x dx minus integration of sec square x dx. We know that integration of cosec square x dx is equal to minus cot x minus, and integration of sec square x dx is equal to tan x plus c, where c is the constant of integration. Ninth question is integration of dx divided by sin squared x cos squared x. This is equal to integration of 1 into dx divided by sin square x cos square x. This is equal to 1 we write as sin squared x plus cos square x divided by sin square x cos square x dx into dx. This is equal to integration of sin square x divided by sin square x cos square x plus integration of cos square x divided by sin square x cos square x into dx. This is equal to integration of 1 by cos square x dx plus integration of 1 by sin square x dx is equal to, we know that 1 by cos square x is equal to sec square x plus, and 1 by sin square x is equal to cosec square x. Into dx. This is equal to integration of sec square x dx plus integration of cosec square x dx is equal to integration of, we know that integration of sec square x dx is equal to tan x plus, and we know that integration of cosec square x dx is equal to minus cot x plus c. Therefore result is equal to tan x minus cot x plus c, where c is the constant of integration. 10th question is integration of x cube plus 5x square minus 4 the whole divided by x square into dx. This is equal to integration of x cube by x square plus 5x square by x square minus 4 divided by x square into dx. This is equal to integration of x plus 5 minus 4 by x square into dx. This is equal to integration of x plus integration of 5 dx minus integration of 4 by x square dx. Integration of f of x plus g of x plus phi of x the whole of dx is equal to integration of f of x dx plus integration of g of x dx plus integration of phi of x dx is equal to integration of x dx plus integration of 5 dx minus 4 integration of 4 into x raised to minus 1 by 2 minus 2 dx, x raised to minus 2 dx. This is equal to integration of x dx plus we can take 5 outside of integration, 5 into dx minus 4 we can take outside of integration, minus 4 into x raised to minus 2 dx. This is equal to, we know x raised to 1, this is x means x raised to 1, this is equal to x raised to 1 plus 1 2 divided by 2 plus 5 into integration of dx we know it is x minus 4 into integration of into x raised to minus 2 plus 1 divided by minus 2 plus 1 is equal to x square by 2 plus 5x minus 4 into x raised to minus 1 divided by minus 1. This is equal to x square by 2 plus 5x plus 4 divided by x plus c, where c is the constant of integration. Eleventh question is integration of tan square x dx. We know that 1 plus tan square x is equal to sec square x. Therefore, tan square x is equal to sec square x minus 1. Therefore, this is equal to integration of, instead of tan square x, we put sec square x minus 1. Therefore, integration of sec square x minus 1 into dx. This is equal to integration of sec square x dx minus integration of 1 dx. This is equal to, we know that integration of sec square x dx is equal to tan x. Tan x minus integration of dx is equal to x plus c, where c is the constant of integration. 12th question is integration of tan square x plus cos square x whole into dx. But we know that 1 plus tan square x is equal to sec square x. Therefore, tan square x is equal to sec square x minus 1 and 1 plus cot square x is equal to cosec square x. Therefore, cot square x is equal to cosec square x minus 1. Therefore, this is equal to integration of tan square x. We can write as sec squared x minus 1. This is sec squared x minus 1 plus, instead of cot square x, we write as cosec squared x minus 1. Cosec squared x minus 1 the whole into dx. This is equal to integration of sec squared x plus cosec square x minus 2 into dx. Integration of sec square x dx plus integration of cosec square x dx minus integration of 2 dx. This is equal to, we know that integration of sec square x is equal to tan x, and we know that integration of cosec square x dx is equal to minus cot x minus 2 into integration of dx is equal to x plus c, where c is the constant of integration. 13th question is integration of 3 raised to x plus 2 dx. We know that a raised to m into a raised to n is equal to a raised to m plus n. Therefore, we can write 3 raised to x plus 2 as 3 raised to x into 3 square dx. This is equal to integration of 9 into 3 raised to x dx. This is equal to 9 into integration of 3 raised to x dx. Integration of 3 raised to x dx, you compare with integration of a raised to x dx is equal to a raised to x by log a. Instead of a, there is 3. Therefore, this is equal to 9 into a raised to x means 3 raised to x divided by log a. Log of a means 3, log a. That is equal to 9 into 3 raised to x by log 3 plus c.